Hi everyone, it's Mike Levin, Tuesday, June 14th, around 9 a.m. 2016, and I thought I would use my walk into work this morning to talk about Python execution contexts. There are actually quite a few of them, and the biggest split is the choice between Python 2.7 and 3.x. I believe it's up to 3.5 is the most popularly used 3 version, and it's a pretty big split in the Python community because there's a lot of code that's been deployed on 2.7, and unlike prior versions of Python, they had decided to break compatibility moving forward in order to work out some of the fundamental underpinnings, mistakes that they felt they made the first time, or adjustments to evolving realities, mostly having to do with making all string or character data types Unicode by default under Python 3. It was a big move forward, with the other data type split at that level being bytes. And under 2.7 it was a little more loosey-goosey, interchangeable. So for a language that declares that there should be one and only one true way of doing a thing, it's pretty interesting that right off the bat you have to choose between Python 2.7 and 3. Whatever. I guess 3.4, 3.5 are the popular versions right now. And I am rebasing myself on 3.5, and none of my code is so far in that I wouldn't actually prefer to restart it from scratch and do things better yet again. So my project, which is like Pipulate, has been around in various forms over the years, in forms that are fairly close to Pipulate. Pipulate is the second. 360i Tiger was the first. They were both implemented on Python. Tiger, as I was brand new to Python, and Pipulate as I was getting a little more familiar. But between the two, there were already dramatically different code execution context differences. The first one was running in Apache under mod Python, which actually didn't use a very popular web API that everyone in the Python world had jumped onto the bandwagon, WSGI. And when I did my second version, I got a web server out of the picture entirely, except for the default one that's actually built into Python itself. So on top of that, I used the Flask micro framework, but already you can see there's all these subtle little differences. There is no such thing as Node.js or Ruby on Rails, only one built-in web server. In Python, there's tons of options, almost too many. And that's even just with the native or default Python execution runtime. It's an exe or an elf, whatever. You know, it's basically the compiled Python interpreter called CPython, which is the language reference specification, because it's not saying it's the only one that there should be. In fact, there are many others that optimize for different use cases, such as PyPy and Euphora. PyPy, which is optimized for fast execution, and Euphora, which is optimized for parallelism. And so you can just swap these things off, usually having to make a few changes in the code as you go, or more than a few, because they really alter the language a little bit, these different runtimes, because you're optimizing for special use cases, and the objects you're going to use in those use cases are often subtly different. But the biggest difference, or the biggest change in the way I'm working in rebasing on Python 3 is not from the runtime or the execution file, but rather it's from this sort of larger context of where your code executes from. And I have always been a minimalist when it comes to integrated development environments and all these fancy things you can do to make writing your code better. And for example, you can use things like Visual Studio with Python, which when you move your mouse pointer over a variable name, it can show you all the objects or methods that are available under that name. And a lot of people, it's sometimes called IntelliSense, and people find that a great help. And when it comes time to run your code, you can hit a hotkey and it executes your code right away. And you can install breakpoints to stop execution at certain points and inspect the variable values there. And I just never really went that route. I found that the advantages of the Vim text editor far outweighed the advantages of an IDE. And I have used IDEs from time to time in other languages. But really, I like to get into the zone or the flow. And text editors like Vim really help you mentally transform yourself to another place. And it becomes all about the structure and the logic, and it's all in your head. And when you think of where you want to be in your own program, you just hit a few keys almost without thinking about it, and you jump to that location. And you do lose a few things that the IDE gives you, but you gain back an awful lot. And then when your code is actually intended to be run on, say, a remote web server, which I really love doing, because when your code execution is on another machine than the one you're sitting on, you can really control the conditions. You can put one version of Python, one version of pip, and make sure that you have no incompatibilities. And essentially you do this dependency isolation just naturally by virtue of configuring your servers, instead of this sort of convoluted process that people do on their desktop machines to control which Python exe that they're using, and control all the dependencies, sort of funneling them all into a particular isolated location. And that's Virtualenv. And this thing called Anaconda that I'm using lately has its own built into its system called Conda. So Anaconda has a Conda. I guess it's a software repository, but it has the functions of Virtualenv built into it. And I've been working on desktop execution environments more often because you have a little more power. It's right there in front of you. The code sometimes executes faster. And this has not been a practical thing for me until recently, because I really switch my platforms around so much, like the shell game, that sometimes I'm on a Windows machine, sometimes I'm on a Mac, sometimes I'm on a Linux machine. And that's really the worst thing in the world for keeping your code running, because the execution environments vary so dramatically. And when you do use Virtualenv, things get a bit more complicated, and I couldn't even use it on Linux, so I just sort of put that to the side for a long time. But now that I'm executing off my desktop and also working on lots of different platform types, I have found that this package called Anaconda, I believe from Continuum, handles a lot of that platform craziness really well. There is compiling dependencies when you install packages. They're keeping your paths correct so that when you refer to things, it looks in the right place. And there are probably literally thousands of tiny details along those lines that can go wrong. And the more components you use, the more packages you use, the more that can go wrong. And the more powerful these components and packages are, like NumPy with optimized compiled C as part of the install, even more can go wrong. And these are things that people want to use all the time, especially these days with data science, where almost everything is based on NumPy built on top of it. So you got your pandas, which is built on NumPy, which has great difficulty getting installed on different hardware platforms other than Linux. So the Anaconda people solved all that, and I'm starting to use it, which makes desktop execution of Python a much greater reality. And hand in hand with that is something that used to be called IPython Notebook, which is now called Jupyter Notebook, which makes it even better because it is a web-based interactive console for experimenting with your Python that lets you save breakpoints. It's kind of like a little Git system in itself, and that you can save versions as you go. And it packages everything together, keeping a history of what you did and even your output, so you can reproduce your whole process and show people everything you did from, say, the moment you imported some data to the moment you made some chart or graph on it to show some amazing insight. And it's really made for the data science people, because it's easy enough to produce a beautiful chart or graph. It's another thing entirely to prove to people that it's insightful, useful, correct. And one of the ways you do it is you rigorously keep track of all your steps so that people can step through it and go, So that's Jupyter Notebook, IPython Notebook. And it also happens to be a wonderful environment for people who are not quite sold on integrated development environments, IDEs like Eclipse, Xcode, Visual Studio, but still want a lot of those same advantages in a more free-flowing, use it when you need it as you're developing kind of way. And that is precisely how I'm working now. I'm making the rounds to all my machines, 2 different Mac laptops, 1 Mac desktop, 1 Windows 7 machine, which is my work-provided machine, 1 Windows 10 machine, which is my Surface Pro 4, and who knows what else. I'm even toying with the idea of how much of this I can get on my Android phone. It won't be very practical, but you know, running Python on your phone and pulling your latest Git repo stuff and doing some quick experimentation and even maybe starting a batch job up is very appealing, very tempting. I certainly had that goal in mind while I was making Pipulate. And this whole development environment, and namely using Jupyter Notebook as sort of a development front-end facilitator, something that's right there running along with Vim, where I still maintain most of my code, committed and pushed up to the GitHub repo. But before the code gets into those text files, they live for a little while in Jupyter Notebook, where I can rapidly experiment. And actually, I'm even starting to think I will keep that as part of the recommended Pipulate environment, because it'll get rid of the notion that it's supposed to be like a traditional web app. It will look, run, and feel and work differently than a traditional web app, and it will have the bandwagon, the groundswell support that Jupyter Notebook has been enjoying. And it will be familiar to a lot of people, and it will sort of segue into a lot of more data science-y projects I plan on taking on. And it just really, in all the ways I think are advantageous, sets me up for my next stages in Python coding and my career. You know, the expanding of what it means to be an SEO, a search engine optimizer, as Google continues to radically change and the types of investigations you need to do become exactly more of the type that Jupyter Notebook was made to carry out. So there you have it. My videos recently have been documenting that process, and I just about have the version 1 of a working Pipulate replacement going, which I'll be using to store some search engine ranking results into Google Spreadsheets. Thanks for joining me. Hope to talk to you again soon, and don't forget to subscribe.